Alright, in this video we're going to look at Euler's number, E, for natural logs. We're going to kind of just take it slow a little bit with this. Make sure we understand the idea of natural logs. E is not bad, but natural logs throws some students off. We kind of watched that video on Friday. The number E, it is what we call the natural number. It has a value. It is irrational. And the value is around 2.71828 ... It is an irrational number like pi, but it is a number. So even though we use the letter E for it, it is a number, not a variable. Now, E is located in a couple spots on the graphic calculators for it. The two spots you're going to be primarily using it, and the one I use is right below log. I'll hit the log button. You can see it red. Right below log, you see ln, and so now you see I hit ln. Above ln in blue is e to the x. So if I hit second ln, that gives me e, but if I hit enter, error, I hit go to, I need to type into power. So if I just want e, I do e to the first power. And there it is, 2.718281828 ... By the way, though it looks like it repeats, it does not repeat. That's just a coincidence. So second ln, that's the first location for E. The next location for E is if you look right above the division sign. So hit division, you can see in red right there. Right above it is your blue. It says E. So hit second divide. That's E itself. I hit enter, it's going to give it to me. So second ln, and I use second ln. That allows me to do powers. Second divide just gives me E for it. So there's where it's located on the graphing calculators. So if I want to insert a power, second ln. If I just want E by itself, second divide. And we can use our calculator to figure out the following. If I want to do e to the eighth, and we'll do e squared, we'll do them both at the same time. So again, notice I had a power, so I'm going to do second ln e to the eighth. Hit enter. I get 2,980.957987 ... goes on forever. Now the next one we want to do is e squared. By the way, I can use second divide and just hit the square button. So I can still do powers with second divide. Hit enter. There are my two numbers, 7.389 ... So I have my e to the eighth and I have my e squared. So e to the eighth was 2,980 point, we'll go to four places, 95798. And so that 8 is going to round up that 9 to a 0, which rounds us up to an 80. So it's approximately 2,980.9580. Our e squared, we'll go to four decimal places, so 7.38905. So that 5 is going to round that 0 up to a 1. So it's approximately that. And I can keep going to the other ones. So the other ones I'm going to do is a e to the 1/2 power for us. And the last one's going to be, just type it in the way it appears, it's going to be a 5 e to the -3rd power for us. So let's check those out. Figure out what I have. I'm going to do second ln, because that's what I like to use. And 1/2 power, so I'm just going to type in 1/2. It stays in the superscript, so I'm good. Hit enter. I'm going to type in 5. I believe it was second e, and it was a negative power, -3rd. Hit enter. There are my two values for it. So we're going to type those. We typed them in. We're going to write them down. So I get 1.64872. That's approximately it. Well, the 2 does not round the 7, so we leave it alone. 5e to the negative third, that was 0. Well, approximately 0.24893. That 3 is not going to round that 9, so we are good. So now we know where it's at in our calculator. We can actually start evaluating the further we go with that. So that's not our logs where it goes through. It's our just where's e in the calculator. So let's move on. We're going to go back to our question. The question for logarithms. A logarithm is, hey, what power of blank gives you blank? And this power in this base is going to be the same. So I'm just going to treat it like this was previous material. I'm not even going to think about E being special. I'm not going to like, what is ln? I'm just going to treat this like we did before. So if I read number 1 and I go, hey, what power of, it looks like E is my base. So what power of E gives me 24? And that power is X. So we can go back through, and if I write off to the side, you know, my base is E, my power is X, and my number is 24. And I could, to help out, write down, let's do this above it, log base B of n equals, that's our question. What power of blank gives us blank? And we find the power for it. So I'm just doing that every time. So let's try the next one. And we could label, if it helps you, that this is your B, this is your P, and this is your N. So now I have all my information. I can use this if I need to. I'm going to use the question. Hey, what power of E gives you 40? And the power is X. I can keep going. And I go, what power of E? 18, and that power is X. I know it's E. I know it's a variable, and you think it's different, but it's no different if I said 3 to the X equals 10. You would tell me what power of 3 gives you 10? X. It's just rather than 3, I'm using E for it. It didn't change the question at all. Our question for logarithms is always constant. Hey, what power blank gives you blank? So this is no different than 8.2 and 8.3 and 8.4 for us. So what is so special about it? Why do we use E, or why do people get confused with E? And E is irrational, we said. It's used in continuous growth, continuous decay problems. We said it's approximately 2.71828 dot, dot, dot. Here's what you have to realize. Mathematicians got lazy. Is rather than writing 4 letters down, log base E, log base E, log base E, instead of writing those 4 letters down, mathematicians use ln. And that's it. ln means log base E. They are the same thing. So though I'm using 2 letters here, this is what they mean. And that just blows the minds of students. It's how is it different? How is it different? It is no different than what you just wrote down above, except for it's shorthand. And that's all. The one thing you have to realize is, and this is the last part we'll go through before we go and kind of solve the other problems. ln of E is unique. And I'll write it like this. Hey, what power of E gives me E? Well, it's 1. And the reason why this is important is because they are inverses of each other. ln and E. They will cancel each other out. And that's going to help us with solving, by the way. And that's kind of what this idea is about. Why we look at this is to cancel out E, I use ln. To cancel out ln, I use E. Kind of like to cancel out division, I multiply. Cancel out multiplication, I divide. They're opposites, they're inverses, so it's going to help us for solving. So we're going to come back to this. But it's here to kind of hold on to. This is where we're going to focus first. It says now solve using this. So let's see what that means. I'm a mathematician and I'm lazy. So rather than writing log base E, I'm going to write ln. So ln of 24 equals x. Well, that's simple. There's an ln button on my calculator next to the number 4. ln of 24. 3.1781. X is approximately 3.1781. We solved it. So really, we solved it up here. We just got lazy and decided to write 2 letters instead of 4. Let's try to see if that worked here. Mathematicians are lazy. So rather than writing down log base E, we write ln. ln of 40 equals x. That's just like the other problem for us. We can type that in our calculator as well. ln of 40. 3.6887, so 3.6889. This is approximately 3.6889. It worked just as easy. There's no way to go 3 for 3. Let's see. We'll do pink. Mathematicians are lazy. ln of 18 equals x. Looks like it is going to work the exact same way. And I'm not going to pull up the calculator for it. I'm just going to tell you guys that the natural log of 18 is around 2.890, and I'll round up to 4. There we go. So what is ln? ln is log base E shorthand. It's laziness. 2 letters instead of 4. So much faster to write down. It's half the time even. So we're going to just take our time, and if you need to do this, I'm okay with that. I want you to recognize what ln is. It's not a special, unique idea. It's log base E. It's shorthand. It's nothing to get hung up on. You've dealt with this for an entire chapter now. Now, be lazy. All right, so some properties of logarithms. I'm sorry, properties of natural logarithms. But I didn't write natural logarithms down. Notice I wrote log base E. So we have our product rule for logs. Well, that's a product rule for all bases that work. So our product rule for natural logs is if I'm adding 2 natural logs together, then I multiply to combine. Well, look, it's shorthand. Your properties of logs, the product rule, it's the same idea for natural logs because natural log is a log just of a specific base. So let's see, is quotient rule the same idea? I mean, it looks like it. Log base E shorthand is ln, so natural log of x. Log base E of y shorthand is natural log of y. Let's see, log base E shorthand is ln of x over, so is this true? When I subtract logs, I did division. When I subtract natural logs, I do division. It's the same quotient rule as it was for logs because that's what ln is. ln is a unique logarithm. It's not anything special. It's shorthand for 4 letters. So I'm going through this and trying to show you, wait a minute, if you know this, log base E, and you have a power, the power gets brought down to be a coefficient, it still works for natural log on it. It doesn't matter that it's 2 letters. It stands for 4 letters. Letters that you know. You know log and a base. You know log and a base. So let's try it out. I want to write each expression as a single logarithm using the properties of logs. So I can do this. I can remember my properties of logs. We can do it two ways. I'll do it in blue and green. Is again, we are adding, which means I'm doing my product rule. And if I'm not afraid of ln, I can just write ln, and I am going to multiply my x plus 3 and my 8 together. And that's going to give me natural log of 8x plus 24. And that's it. It's the same as if it were log of x plus 3 plus log, wait a minute, it's base e. I put that base e in the wrong spot. It's base e. So let's see if that changes. Well, if I do log, and I know it's base e of x plus 3 times 8. Let's see, that does give me 8x plus 24, so that's nice. And we did learn log base e means ln. But it's the same thing. So it's the same as using log base e. I'm just using ln's. I like this. This is much faster. I only have to write down 2 letters. Man, I had to write down 4 letters here, 4 letters here, 4 letters here. That's 12. Then I had to write down 2 more to convert it, so there's 14. Let's see, 1, 2, 3, 4. I only wrote down 4 letters. 4 letters instead of 14. Again, mathematicians are lazy. They don't want to write that. They want to write this much faster. So when you see this, I mean, instead of writing it every time as log base e, just boost your confidence. Just write this off to the side. So I'm subtracting logs, which means quotient rule. You're doing division. So ln of 7x minus 8 over 15. Done. That's it. I'm good. Nothing to see here. Can't do anything else. I just want to write it as a single log using my properties of logs. That's all. You could also, and I can allow this, is maybe put an E down there and make you feel a little bit better because you see the base. I don't know. But in this case, I have a power of 4. So that power is going to come down. I'm going to get 4 times ln of 5x. And there we are. And that's all your expansions with the properties of logs. Sorry, the properties of natural logs. It's going to be hard for me not to say properties of logarithms because it is the property of logarithm. Just shorter amount of letters to write down. So let's try the next one. Solving. So in order to solve for base e, we need to isolate e. Actually, scratch that. We are going to end here. So now that you know that log base e is the same as ln, approach the homework that way. Build your confidence today with what ln is, and we will come back tomorrow with the solving on it. So we'll focus primarily today with confidence, with our shorthand for it. ln is log base e. Get used to that, get used to the calculator, and then on Tuesday we will work on solving.